Greetings and welcome. In today's video, we're going to talk about solving quadratic equations by factoring. And the big idea for using this technique is the zero product property, which says for any real numbers a and b, if a times b equals 0, basically the only way this can be true is if one of these numbers, or both, were originally 0. Right? So zero product property. And we're going to use that as a means of solving, where if I can rewrite my quadratic as a product of things multiplying to be 0, then I can break it into separate equations equal to 0. So let's solve the following problem. What if I've got 16t squared minus 48t equals 0? So here I've got a difference of two terms equal to 0, so I can't assume that this is 0 or this is 0. I have to somehow write this as a product. So to factor this, I'm going to, in this case, I can yoink, steal out a greatest common factor, which I believe I could take a 16 out of both of those, as well as a t from both of those. So 16t times what equals 0? So 16t times t is 16t squared, and times negative 3 would equal negative 48t. So now I do in fact have a times b equals 0, so I can break this up into two cases. Either 16t is equal to 0, or t minus 3 is equal to 0. And now I can solve each of these. So over here I divide by 16, over here I add plus 3 to both sides, and I will end up with t equals 0 or t equals 3. And if I wanted to, I could even do a check in the original problem and verify that that works. Now when solving quadratics, frequently we'll have two solutions, as many as two solutions, although it is also possible to have no solution or just a single solution as well. So there's our first example where I was able to factor using greatest common factoring as my technique. Suppose I have this problem that I want to solve. X squared plus 6x minus 16 equals 0. So here I can't factor using greatest common factor, although it's always good to check. However, I do have my a is 1, so I can factor this using kind of my classic factoring technique. So I'm going to find the factors of c that subtract to b, alright? And that b in this case is a 6, although it looks like a b as well, I suppose. So the factors of 16 are 1 and 16, 2 and 8, and 4 and 4. And which of those subtract to be 6? I believe that's the 2 and the 8. So I can now break this up into x with a 2, x with an 8 equals 0. And now to figure out the signs, well, they multiply to be negative, so their signs have to be different. And they add to be positive, so the more influential number must have been the positive one. So plus 8 and minus 2. And now, lo and behold, notice I've got two things that multiply to equal 0. So therefore, either x minus 2 equals 0 or x plus 8 equals 0. And I solve each of these. And I end up getting my two solutions once again in this case. So either x equals 2 or x equals negative 8. That looks like a lambda almost there. There we go, fixed it. And if I wanted to, I could even do a proper check plugging these in. 2 squared is 4, plus 6 times 2 is 12, 4 plus 12 is 16, minus 16 is in fact 0. And I believe even the negative 8 should work. Negative 8 all squared is 64, plus 6 times negative 8, what's that? Negative 48. So that's combined to be 16, and minus 16 is 0. So both of those, in fact, even work out. So, so far the two examples I've given are ones in which we already had them set equal to 0 from the start. So that's not always going to be a guarantee for us. So I think I might be able to get away with just a single additional problem Let me actually see if I can be clever enough to make one up. Not always the case, but what if I've got 3x squared, let me throw an equal sign here, equals, let's say, 10, and I'll do plus x over here. So 3x squared plus x equals 10. Now, even though I could greatest common factor an x out of those first two terms, it won't be helpful unless this is first equal to 0. So that's going to be my first move, is set it equal to 0. So subtract 10 from both sides, and I will get 3x squared plus x, minus 10 equals 0. And now I can factor this and set each factor to 0. So in order to factor this, well, I do notice that I can't use my classic technique because a is not 1. So I'm going to use the AC method. So a times c, 3 times negative 10 is negative 30. So let's find the factors of 30, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And which of these will subtract to be 1? There's a little invisible 1 hiding there. 5 and 6. So now we do the split the b term into two like terms. So these are going to be x terms, right? So an x and an x. And the coefficients of these terms are going to be the factors that we just found. So I'll have a 5 and a 6. And it doesn't actually matter which order you put it in. Some people would want to put the 6 here and the 5 here, merely because 5 goes better with 10 and 3 goes better with 6. It actually won't matter or change our answer. It'll just change our work a little bit. And let's see, so 6 and 5, they multiply to be negative 30, so their signs have to be different, and they add to be a positive 1, so the more influential one must be positive. So it's a positive 6x and a negative 5x. And now I can factor by grouping, where I'm going to GCF the first two terms and GCF the last two terms. So the first two terms, the greatest common factor is 3x, and the last two terms I can take out a 5, but better yet, let's take this minus sign out with it. And in fact, we will have to take that minus sign out. It won't work out if we don't. Let's see, so I've got 3x times what would be this, so that would have been x, 3x times x is 3x squared, and 3x times 2 would give us a 6x, right? I believe that checks out. Negative 5 times what is negative 5x? That would be an x. And negative 5 times what would give us a negative 10? That would be another plus 2. And now it actually, both of these sets of parentheses do have to match in order for this to work. Because my next step, I'm technically GCFing out this entire set of parentheses. Kind of a really abstract way to do it. But I'll end up with an x plus 2 times whatever was left over, 3x minus 5. So there's a pretty decent review of the AC method. But what was our purpose behind it? Well, I had an equation equal to 0. I wanted to factor it, because now I have two things that multiply to be 0. And what do I know to be true? Either x plus 2 equals 0, or 3x minus 5 equals 0. Right? So let's solve both of these. Subtract 2, subtract 2. Over here I had plus 5, plus 5. So here I have x equals negative 2. That one is solved. Here I have 3x equals 5, and one additional step, divide by 3. And we're perfectly fine with fractions existing. So x equals 5/3. So those are my two solutions, and both of them actually would work in the original equation, which is excellent stuff. Actually, just even verify, negative 2 all squared is 4 times 3 is 12, plus a negative 2 is 10. It works out. And 5/3 actually would work as well. Well, thank you for watching my video, and I'll catch you guys next time. Bye-bye.